even put the emoji because I know we love it. All right. I'm trying to think of the best way to do this. So you can play the guess or check method, but let's kind of do something we actually have already done. So do you remember when we did radicals, we set the inside equal to 0 to figure out where our starting point is? Oh, that graph got cut off. Hold on real quick. Oops, we'll just fix that later. So when we did like absolute value functions and we were trying to graph it, we had like x minus 1. And I always said set the inside equal to 0. And that's kind of like it's all for x, which would be 1. That's like your starting point. We're going to do the same thing for 6, okay? Instead of trying to play the guess and check game. Okay, so step number 1, set inside, wow, I'm dyslexic today. Set inside equal to 0. So we're going to do that right here, right now. The inside is, wow, that looks atrocious. The inside of this radical is x. So we're going to set x equal to 0. So x equals 0, so that's our starting point. Okay. Now, you might say that's obvious, and that's fine. But when something's added or subtracted inside of here, that may be a little different. 2, you're going to then go complete the table. And I'm going to say x are going to get bigger. Yeah, they should. Unless they're reflected, then it's going to be a little weird. So I'm going to use the point 1. And since I have the square root of x, I know these numbers are going straight in there. So I know the square root of 1 works. I know if I plugged in 4, the square root of 4 is 2. And if I plugged in 9, the square root of 9 is 3. So those are some options. You can play the guessing game and just do a bunch of numbers and you can get decimals. That's fine. But I'd rather not. So I'm not going to. So if we plug in 0, you get the square root of 0 plus 5. And that equals 5. Now, why is it 0, 5? Well, that's because right here, this is making it go up 5 units. It usually starts at 0, 0, but it's going to be starting at 0, 5. That makes it be the endpoint, and I want you to tell me which one it is, and then give me the coordinate point, which is 0, 5. So we already have part of it done. Then you're going to plug in 1. You're going to do the square root of 1 plus 5. The square root of 1 is 1, plus 5 is 6. So at 1, we're at 6. Square root of 4 plus 5. The square root of 4 is 2, plus 5 is 7. So we're here. And then we're going to do the square root of 9 plus 5, and the square root of 9 is 3, so 3 plus 5 is 8. So at 9, we are at 8. So the graph looks something like this. Now, because it got shifted up 5 units, that makes the range change. Okay, if it got moved left or right, then it would change the domain. So don't assume the domain and the range are going to be exactly the same as what I did on the first example. Okay, so this graph is not going to go any further than here. That means the left, remember going from left to right with domain. Okay, the most left value is 0, and we can get it, and it's going to keep on going to infinity. And ranges from the bottom to the top. So the lowest value is 5, and we can get it, and it's going to keep on going, so it's to infinity. And that is graphing the first function. Okay, so we need to move this function over here, which means I'm just going to have to memorize it. So go into the next page. And example 8 is f of x equals negative the square root of x, and I forget it, go figure, x minus 1 plus 4. All right, first step, set inside equal to 0. So the inside is x minus 1, set it equal to 0, and you get 1. All right. The other thing you can do is on that first page of notes, I said that the endpoint or the turning point is going to be hk, which is kind of like the vertex. And that would be, this would give you 1, and this would give you 4. So that endpoint, because we're doing square roots, would be 1, 4. Okay, now you're going to get that here, so you're going to see it, but just to let you know, you're able to get that endpoint or turning point right away. So I'm going to use the x value of 1, and then I'm going to kind of think this through. Okay, so you can play the guessing game. Actually, you know what? I'm going to play the guessing game this time just to show you. let's just do those points, okay? So we're going to plug in 1 into here, and doing some mental math, 1 minus 1 is 0. So square root of 0. Square root of 0 is 0. There's no such thing as negative 0, so this equals 4. So proof that that's right. So we have a coordinate point at 1, 4. Then we're going to plug in 2. 2 minus 1 is 1. Square root of 1 is 1, so we get negative 1 plus 4, which is 3. So at 2, we're at 3. Now the question is, why is this going down? Well, it's going down because of this negative right here. So this graph was reflected. It's going to be shifted right 1, and it's also going to go up 4. So those are the transformations off of that. Okay, so then you're going to plug in 3. And 3 minus 1 is 2. Well, 2 is not a perfect square, so it's going to be some decimal answer that I don't feel like getting. So I'm not even going to finish that problem. We plug in 4, and we get square root of 3. Once again, that's not a perfect square, so it's some decimal answer, and I don't feel like getting it. I'm just looking for whole answers because I think it's easier. We plug in 5, and you actually get the square root of 4, which is a perfect square, which gets you negative 2 plus 4, because the square root of 4 is 2, and that gets you positive 2. So at 5, we're at 2. So the graph looks something like this. Okay, so when you do domain, you're going to say, what's the left point, the most left point, and what about the right? So the most left point is right here at x. Remember, domain is x, range is y. I'm going to write this up. So the most left value is 1, and we can get it. And then this graph will keep going to the right, so it's reflected. And the range, the lowest value, is something we don't know because it's going to keep going down and down and down. So the range is actually going to be from negative infinity, and the highest point we have is 4, and we can get it. So that is the graph. Okay, that is graphing square roots. I'm going to do a cube root one, but I'm pretty sure it's not on Khan Academy. So if you don't want to continue with the video, then you don't have to. I totally get it. But if you want to learn about it and write it in your notes, then here we are. Okay, so we do the same thing for this. We set the inside equal to 0, and that would give us negative 1. Now this is different because it's a cube root, so it makes a totally different shape. So that's not going to be, negative 1 is not going to be like our starting point. It's our turning point. So that's our turning point. Okay, so I'm going to put it right here in the middle. And remember how I told you the whole HK thing? Well, this is H, and it's going to be negative 1, and this is negative 5. So I know the turning point is at negative 1, negative 5, but I'm going to mathematically do it. We're going to kind of play the guessing game again to a point, but I don't want to do a bunch of values and do more work than I have to, so we're going to kind of make up the values as we go, just a different approach, and that's okay. All right, so negative 1 is going to go into here, and I'm going to write this out. We have to remember we're doing the cube root now, so it's a little different. You're not finding square roots, you're finding perfect cubes. If you plug negative 1 into here, you get 0. So we have 1/3 times the cube root of 0 minus 5. Well, that is 0, and anything times 0 is 0, so we get negative 5. So proof that that works. So I'm going to put that first point. Negative 1, negative 5. Okay. Now, if you plugged in 0 into this, so we're heading this way, 0 into this or into here is 1. And any radical with a 1 underneath of it is going to be 1. So you get 1 minus 5, which is negative 4. Okay, so I'm going to do another x value on this side of that turning point, but I have to think of what will work. So if you plug in 1, you get the square, or the cube root of 2, which doesn't have a perfect cube. Plug in 2, 2 plus 1 is 3, not a perfect cubed. Plug in 4, 4 plus 1 is 5, and there's not a perfect cube. Let's skip a number. If we plug in 7, 7 plus 1 is 8, and there is a cube root. So I have to jump all the way there to get a perfect cube. Now you can do decimals, there's nothing wrong with that. I just don't feel like it. Okay, so and the funny and ironic thing is we're going to get a decimal anyway. So the cube root of 8 is 2. So that gives us, this is 2. So we get 2/3 minus 5, which is 5 1/3. Yes, I'm shocking you. I don't usually like to do that. So 5 plus 1/3 is obviously 5.33. I'm embarrassed I put that in my calculator. So I'm going to go to 7, and it's just a little bit above, whoa. Sorry, it's not negative. It's 4 2/3 because there's a negative right here. So that makes it negative 4.66 repeating. So negative 4. Am I losing my mind? I might be losing my mind. Cube root of 8 is 2. 2/3 minus 5 is negative 4.33. I think I made a mistake somewhere. Let me check out. Okay, so we have 1 over 3, and then you guys are just going to have to work through this mistake with me because I am not starting this video over. Negative 4.33. Oh, I see where we made the mistake. Okay, this point's wrong. I'm hoping you caught on to that. Okay, if you didn't, that's okay. This has a 1/3 out in front of it, and I totally forgot about it. So we actually have 1/3 minus 5. So 1/3 minus 5 is negative 4.66. This, I'm going to erase because this is just a mess. Oops. Ooh, this is bad math here. 2/3 minus 5 is negative 4.33, repeating. Okay, so we actually have a point right here. So this thing is not going to grow very much, and that's because that 1/3 is compressing it. So we have a point like somewhere in here, if it's going to let me make a point. And then clear at 7, we have another point like right here. So you're going to notice this thing's not going to grow very much on that side. So this is going to look really bad. Let's just do negative 9. So I'm doing negative 9 because negative 9 plus 1 is negative 8. So we get 1/3 cube root of negative 8 minus 5. That gets you negative 2/3 minus 5, which is negative 5 and 2/3. So negative 9, 5's right here, so it's somewhere down in here. So this graph is looking real rough. Wow. I don't even know if I can complete this with the way this thing is. It's so awkward. So the graph should look something like this. Okay, that's what it should look. This is what happens when you use a tablet. So holy crap, is that bad? The domain of this is going to be negative infinity to infinity, and the range is going to be negative infinity to infinity. That I can guarantee with cube roots. All right, again, I don't think that's on Khan Academy, so you're safe there. If you have any questions, just get a hold of me. Thanks, bye.